Welcome to all of you. Today we discuss about practical number 17, divided difference interpolation, numerical practical by C programming. And this is the C programming. This is the divided difference interpolation problem 17. Write a C program to compute the value of fx at 0.79 plus r plus 1 divided by 1000 and at 0.98 minus r plus 1 divided by 1000 by suitable interpolation formula from the following table. These are x and fx are these, where r is the last digit of your SU roll number. Obviously, it is clear from the table this x 0.75, this 0.79, this 0.86. So these are not equally spaced, and these arguments are not equally spaced. So we may apply either divide difference interpolation or Lagrange's interpolation method. This method is this double. What is the method? Actually, what is the divide difference method? So first we discuss preliminary discussion about the divide difference method, and then come to the C programming here next. This is the divide difference interpolation table. This is the x are nodes here. We taking here 6 nodes x0, x1, x2, x3, x4, x5, and this yi corresponding the value of fxi, this y0, y1, y2, y3, y5, y5, and delta yi is the first order divided difference is defined by delta y0 equal to the divided difference this f within third brackets x0 comma x1. Actually, what is the definition of this first order difference? This delta y0 equal to f x0 x1, that is equal to fx0 minus fx1 by x0 minus x1. Fx0 means y0 minus y1 by x0 minus x1. So this is the first order divided difference for delta y0. Delta y1 is f of x1 x2. So delta y1 is the f of x1 x2. This of f of x1 minus f of x2 whole divided by x1 minus x2. That is y1 minus y2 by x1 minus x2. So delta y2 is equal to this y2 minus y3 divided by x2 minus x3. Delta y3 is equal to y3 minus y4 divided by x3 minus x4. And this delta y4 is equal to y4 minus y5. This is equal to whole divided by x4 minus x5. Second order divided difference, this delta 2 y0, this is equal to f of x0 comma x1 comma x2. So this is equal to delta y0 minus delta y1 divided by whole divided by x0 minus x2. Delta 2 y1 second order difference, this delta 2 y1 is equal to f of x1 x2 x3. This equals to delta y1 minus delta y2 whole divided by x1 minus x3, x1 minus x3. So this is the second order differences. This delta 2 y0, that is equal to this delta y0 minus delta y1 by x0 minus x2, and delta 2 y1 is equal to f x1 comma x2 comma x3. This equals to this delta this delta y1, this delta y1 is this f x1 x2, and x2 x3 is the delta y2 whole divided by x1 minus x3, and so on. And the third order divided difference, and this way, delta 4 and delta 5. And this is the differences. First we uh, calculate this divide difference. This double variable, this is the long floating, that is the LF, is one dimensional array x20 y20, and these the differences, divide differences, that is first order or second order. This sum, term, and x6 and one dimensional array is 5, contain 0 to 4 x6. This x6 means that this is the given value of x. This is the 0.79 plus r plus 1 by 1000, and this x6 1 equal to 0.98 minus r plus 1 divided by 1000. And integer variables are name, j, I, j, k, and r. Enter the value of r, the last digit of your roll number, and this scanf percentage d ampersand r. And total number of interpolating points, that is n equal to 6, because this 1 2 3 4 5 6, so n equal to 6, and the total number of interpolating points is 6. And here n equal to revised value of n, that is equal to n minus 1. Actually this n minus 1 is the total number of sub intervals, in this problem. So interpolation problem for n plus 1 points. So actually n plus 1 points means this is the 6 points, 6 interpolating points. So this is the 5 plus 1 in divided difference interpolation, 5 plus 1. So here n equal to 5 here. The given interpolating points are these x0, x1, x2, x3, x4, x5, and these are given here. And y0, y1, y2, y3, y4, y5 are these, and the values of xi for which the interpolation are required. This x0, this 0.79 plus r plus 1 divided by thousands, 0.0 semicolon, and x1 is equal to 0.98 minus r plus 1 divided by 1000.0 semicolon. Now we calculate the divided differences. For I equal to 0, I less than equal to n, I plus plus. So d I0 equal to yi. Actually when I equal to 0, so this d00, actually d00 equal to y0. And next I equal to 1, so d00 is the y0, d10 is the y1, d20 is the y2. Actually this di0 gives the values of yi, gives the values of yi. Next for j loop, j equal to 1, j less than equal to n, j plus plus is j means for the jth order divided difference. When j equal to 1, this is the first order difference. J equal to 2 for the second order divided difference. This second order divided difference, this is the first order, that is the delta y for j equal to 1, j equal to 2 delta 2y, j equal to 3 delta 3y, j equal to 4 delta 4y, and so on. So this next for I equal to 0, I less than equal to n minus j, I plus plus. So when j equal to 1, this I equal to 0. So I equal to runs from 0 to up to n here 5 minus 1, that is equal to 4. So in the first loop when j equal to 1, I runs from 0 1 to 4. Actually j equal to 1 means the first order difference. So I equal to 0 1 2 3 4, that means I equal to 0 0 1 0 0 1, I equal to 1 1 2 1 3 1 4 1. So when j equal to 1 and I runs from 0 1 2 3 4, so we get the from the table, divided difference table, we get the first order these differences of this delta y0, delta y1, delta y2, delta y3, delta y4. So this is called delta y0, that is equal to d01. Delta y1, that is d11. This second one stands for the first order divided difference, and this 0, this first one, this one, and delta 41, delta 41 is the this so delta 41 is this delta y4, that is equal to first order divided difference, and delta y4 is equal to this. Next I j equal to 2. So when j equal to 2 is the second order differences. So I runs from when j equal to 2, j equal to 2, and I runs from this equal to runs from 0 to 0 to 0 to this n equal to 5, 5 minus 2, that actually this 3. So this is the j equal to 2, second order difference. So second order difference, so delta 2 y0, so delta 2 y0, delta 2 y0, delta 2 y1, delta 2 y2, delta 2 y3. So when j equal to 2, we get this delta delta 2 delta 2 delta 2 y0 delta 2 y0, this d20 d2 sorry d02 d02 delta 2 y0 d12, this is the delta 2 y1, d22, that is the delta 2 y2, and d32 delta 2 y3, the second column. So when j equal to 2, we get these the second order differences, these delta 2 y0, delta 2 y1, delta 2 y2, delta 3 y3. And so this j equal to up to n, so j up to when n equal to 5, last value of n this 5, this, so we get this the last column, this only one element delta 5 y0 here, this. So now print the difference table, this divide difference table, this for I equal to 0 to I equal less than equal to n I plus plus, j equal to 0, j equal to n less than equal to n minus I j plus plus. Print percentage 15.12 lf, this lf long floating, that is the double, because d is double variable, so this dij. So when I equal to 0 and j runs from 0 to this n equal to 5, so 0 to 5, so 0 to 5 I equal to 0, j runs from 0 to 5. So for I equal to 0 and this d 0 0 d 0 1 d 0 2, so we get printed this way, this the row wise print, this is the y0 delta y0 delta 2 y0 delta 3 y0 delta 4 y0 delta 5 y0. So we get this the first, this the row wise print this, and this I equal to 2 for the second row, print the second row, that is from the table, this y1 delta y1 delta 2 y1 delta 3 y1 delta 4 y1, and in this way we get the difference table. And calculation of the required fxi for the given xi, this we here there are two x here, for 2x, so k equal to 0, k less than equal to 2, because only k equal to 0 and k equal to 2, we get these two values of x, this x0, and we call this x1. If there are three values, so k equal to 2, k equal to 0, k equal to 1, and k equal to 2. Here only two values, so k equal to 0 and k equal to 1 only. K plus plus sum equal to y0. Here the divide difference formula, or Newton's general interpolation formula, px interpreting polynomial, is equal to y0 plus x into x0 into delta y0 plus x into x0 into x minus x1 delta 2 y0 plus x minus x0 x minus x1 x minus x2 delta 3 y0, and this. So we here highlighted this the red color, in highlighted color, and this column with multiply with these x factors, this x minus x0 delta y0, x minus x0 into x minus x2 x1 delta 2 y0. For second order difference, we multiply two factors. For third order difference, we multiply three factors. So when this is the sum, initial sum equal to y0, this is the y0, and term equal to xkk, here xkk means a k equal to 0, so x0 minus x first x minus x0 term, this j equal to 1 to j less than equal to n j plus plus, sum equal to sum, this is the previous sum y0 plus term, that is the x minus x0 into d0 0 1 d0 1. So we get this y0 plus x into x0 delta y0. Next, term equal to terms into x minus x j equal to 1, x minus x1 term means term equal to x minus x0 into this term, the previous term is this x minus x0 into x minus x1. So this is the term. And next for j equal to 2, sum equal to previous sum plus term, so previous sum equal to y0 plus x minus x0 into d delta y0, plus term here x minus x0 into x minus x1 into d 0 2, that is equal to delta to y0, delta to y0. So we get, after g equal to 2, we get this term plus this term x minus x0 into x minus x1 delta to y0, this term. And in this way we calculate up to n terms. N terms means n equal to 5 here. So we get the value of corresponding x, value of f for the corresponding x k equal to 0. And next loop for this k equal to 1, we get the value of f for the second value of x. This is the 0.98 minus r plus 1 divided by 1000.1. And this is the programming of this. First save this program and compile, and then compile, there is no error, and then compile and run this program. So enter the value of r, put here r equal to 5, r equal to in the last digit of your roll number, and enter this. The total number of interpolating points is 6, x0, x1, x2, x3, x4, x5. And the difference table is this first column gives the value of y, that is fxi, is the y0, y1, y2, y3, y4, y5. And this is the first second column gives the first order differences, delta y0, delta y1, delta y2, delta y3, delta y4. And this second order differences, delta 2 y0, delta 2 y1, delta 2 y2, delta 2 y3. Third order difference, delta 3 y0, delta 3 y1, delta 3 y2, and so on. The required values of f at the given x, that is equal to f 0.796 0, this is equal to 1.183836734320211. And the second value for this f equal to 0.9740 is equal to 1.37839987 and 32, so on, so on. And this completes the divide difference formula. And this is the thank you for watching this video, and all are given in the description box. This is the C file and the explanation of this PDF file. And thank you again.